Swayam Prabha. Digital India. Educated India.
In this particular lecture, we will cover this modeling and management of groundwater. Under this, I would cover the topics are aquifer yield and groundwater availability, second topic is effects of groundwater development, and the third and the last one that we will cover is that regional scale development of groundwater. So, first topic is our aquifer yield and groundwater availability. So, in this particular topic we will try to see what is this groundwater. Ground, as if you can talk about this water is generally considered as a renewable resource. Sometimes we deviate from that point of view because groundwater mining is also there. So, the main point is the groundwater water is renewable resource but the problem is the aquifer recharge versus this groundwater withdrawal. This is mostly uneven in nature. So, if a recharge is coming, then we should also consider the groundwater withdrawal from groundwater management point of view, but sometimes uh, there will be situations where our groundwater withdrawal is more than our groundwater recharge scenario. So, what is the main source for this groundwater recharge? So, aquifer is recharged, aquifer recharge is mainly due to precipitation. So, the amount of water, so we can say that this amount of precipitation is limited. So, we can say that our uh, amount of water considered as renewable is limited. So, this is important point because precipitation is limited. So, we can consider that amount of water uh, considered as renewable is also limited in nature. So, for groundwater management projects, it is important to find out equilibrium between this aquifer recharge and ground water withdrawal. So, our groundwater projects or water resources projects this equilibrium between aquifer recharge and groundwater withdrawal is important. So, aquifer yield concepts are the fundamental things for finding out or devising any strategy for or to maintain such kind of equilibrium. So, aquifer yield concept are foundation for devising any strategy to maintain the such kind of equilibrium. So, this is the foundation for any kind of equilibrium concept, and groundwater availability means the amount of water which is available from the aquifer. So, this is mainly groundwater that is available for use from an aquifer. But the problem is it is not easy to define it or to quantify this particular thing that is available for use from an aquifer. So, how to quantify that thing, that is most important aspect of this particular groundwater availability thing. So, this is, we can say that this part is difficult to quantify. So, with simple formulas or equation, we cannot directly calculate this particular availability. To estimate this, we need the numerical groundwater models, numerical ground water flow models for complex hydrogeological scenarios. So, one hand this is difficult to quantify, on the other hand we can use our knowledge about the numerical groundwater flow models to model this complex hydrogeological scenario. So, to quantify the aquifer yield, the first we need to define few terms. So, first term is well yield. First term is well yield. So, what is this well yield? In this thing we can define this well yield as the volume of water per unit of time discharged from a well either by pumping or free flow. So, we can define it as volume of water per unit of time discharged from a well either by pumping or free flow. So, it is commonly measured as meter cube per day. When a water well is pumped, the quantity of water discharge initially is derived from the casing storage, and then immediately from aquifer storage around the well. So, equilibrium occurs when the cone of depression enlarges to the point at which one or more of the following things happen. One is it intercepts enough of the natural discharge from the aquifer. Second thing, it intercepts a body of surface water. Third one is that enough vertical recharge and the fourth one is sufficient leakage occurs through the overlaying or underlaying formations. So, for well discharge for any unconfined non-leaky aquifer is given by Q equals to pi k h square minus small h square divided by log r by small r, where this discharge is the well yield or pumping rate, K is the hydraulic conductivity, then this H is the static head measured from the bottom of the aquifer, static head, and small h is the pumping head, and r is the radius of depression radius of the depression small r is the radius of the well. So, for confined aquifer, confined non leaky aquifer, this Q is 2 pi k b and H, this is again log r by small r, where this b is the saturated thickness or thickness of the confined aquifer. So, a properly conducted pumping test can reveal the groundwater scenario or important facts about any particular aquifer. Next important type of yield is that perennial yield, or so this perennial yield is defined as the practicable rate of withdrawing water from it perennially for human use. So, this word practicable is important here because this practicable quantity or practicable rate is which we need to quantify in case of a particular aquifer, but this practicable means that the adverse effects of any adverse effect or side effects of any groundwater development such as seawater intrusion, land surface subsidence, saltwater coning, these are included in this practicable thing. So, it should be such that there will not be any adverse effect related to the groundwater development. So, perennial yield, we can say that this perennial yield is determined for a specified set of operating conditions So, this perennial yield is similar to the perennial flow in our surface water systems, and the perennial yield from a designated reservoir would be achieved if artificial discharge by the well were pertained so as to reduce the discharge from reservoir and induce recharge in an equal amount, and if storage were utilized only to provide some kind of regulation of the fluctuating inflow and to meet the demand of the well. So, it is important that so it should be under certain kind of operating conditions. So, we can have the next term as safe yield, but this perennial yield of the aquifer can be thought of some kind of engineered controlled some kind of yield, where the perennial in some instances can be substantially by this engineering controls. So, next term is safe yield. So, what is this safe yield? So, safe yield, most of the hydrologists prefer this safe yield instead of this perennial yield, but the problem is that safe yield is such a yield which is not controlled by any other operating condition. Then we can say that this safe yield is defined as the maximum annual withdrawal from an aquifer that still maintains the sustainability of the aquifer. So, we can say that water resources of an aquifer could be maintained indefinitely if pumping does not exceed the safe yield. So, this pumping value or QP should be less than the safe yield. So, the safe yield is a popular concept in groundwater resources management, and it is generally used for different kind of management problems, and this like perennial yield, the safe yield is also difficult to quantify, also difficult to quantify or to determine, because it has no unique or constant value depending on the spacing and location of wells and their influence on the aquifer and environment. Next comes this optimal yield. So, this is determined by using optimization theory, considering socio-economic issues. So, optimal yield of an aquifer is determined by selecting optimal management approach for any particular aquifer. Optimal yield can lead to optimal yield can lead to depletion or complete conservation of an aquifer. So, it is important to distinguish between this optimal yield and safe yield. So, this optimal yield can lead to depletion of the aquifer, whereas this safe yield will maintain the aquifer level or the storage within the aquifer. Next important term is sustainable yield. What is this sustainable yield? Sustainable yield is most useful when applied to well field in situations that Thomas has termed as this. Thomas is a scientist who has termed as water course aquifer. Situations we can say that in field situations of water course aquifers. So, such aquifer such an aquifer generally underlies the floodplain of major river system and is in hydraulic contact with the water in rivers. So, sustainable yield is the minimum. So, sustainable yield is the minimum rate of pumpage sustainable under all conditions of river discharge by a specified well field that tap the alluvial aquifers. So, we have seen that perennial yield, safe yield, optimal yield and this sustainable yield. So, in case of perennial yield, we have seen that we need to maintain some practicable rate of withdrawing water from the aquifer. In case of safe yield, it should be the maximum annual withdrawal from an aquifer that still maintains the sustainability of the aquifer, and optimal yield, this is determined by using optimization theory considering socio-economic. So, here socio-economic issues are important. In case of sustainable yield, this is mostly applicable to water course aquifers, and this is the minimum rate of pumpage sustainable under all conditions of river discharge by a specified well field that taps the alluvial aquifer. Next point that we need to discuss is the effects of groundwater development. So, what are the effects of groundwater development? The first effect is water level decline. So, long term effects on regional groundwater levels, that is water level decline. As long as water is mined, that is withdrawal of water in excess of the induced recharge plus the reduced groundwater discharge from an aquifer, the water levels of potentiometric surface will be continuously lowered in elevation on a year by year basis, and this will create problem, and this problem is due to groundwater development. Second is depletion of surface water. Depletion of surface water is another major reason here, because let us say that this is our groundwater thing, and we have this ground surface. This is our ground surface, and we have water level like this. So, this is basically, we can say that gaining stream where our water level is here, which is above the water level in surface water, this is groundwater. So, groundwater level is more than surface water. So, we can say that as gaining stream. Otherwise, if this groundwater level is below the surface water, then there will be movement of water from movement of water from surface water towards the groundwater body, then we can say that as losing stream. So, this is surface water, this is groundwater level, and this is our ground surface. So, it is important that groundwater development can also lead to either losing or gaining stream. If there is too much of pumping from the aquifer, then there will be depletion of ground water and there will be losing stream situation in the aquifer region. Also, salt water intrusion is another effect that we have already discussed in our previous lectures. Salt water intrusion. So, coastal areas, if there is heavy pumping, there will be movement of salt water towards the freshwater aquifer. And the fourth scenario or fourth important point is that land subsidence and earth fishes. So, land subsidence is gradual settling or sudden sinking of earth's surface owing to surface water movement, and so groundwater development can also lead to surface or this land subsidence, and there may be generation of this fishes. So, next point is regional scale groundwater development. So, at regional scale we need to address the groundwater development issue. So, first is management aspect. So, elements of management plans. So, once management objectives are adopted, activities and costs of planning and investigation must be developed in sufficient detail to obtain authorization funds for the study, and identification of different management aspects should be fixed. And the next point that is most important is that political boundary versus aquifer boundary. So, for finding out the yield for any particular aquifer, we need to have certain groundwater flow models, and in that one we need to have certain boundary conditions. Either we can have political boundary in our regional scale model, or we can have aquifer boundaries. But the problem is that most of the cases aquifers are shared by two or more political regions. So, that creates a problem for any regional scale development scenario in groundwater, and this identification of boundary condition becomes important, and this political boundary or aquifer boundary can be used for modeling purpose. Next aspect that is most important is that transboundary issue. Of transboundary aquifers. So, transboundary groundwater refers to continuous groundwater reservoir, and it is shared by two or more political jurisdictions. So, here the fixing boundary condition is important. Here different management aspects are important, that is joint management plans can be devised for better management of groundwater aquifers. Also, conjunctive use of surface water and groundwater is important from the regional scale development aspect. So, in regional scale the use of river water or the surface water available should be supplemented by this groundwater or water from the groundwater aquifer. So, these are the three major issues related to modeling and management of groundwater aquifer, that is aquifer yield and groundwater availability. Then we have discussed the effects of groundwater development, and finally we have discussed this regional scale development of groundwater. So, this ends this lecture number 38.